So I received a question asking, how do you tell if a problem is a standard simplex or a general simplex problem? And I responded saying, you read the answers and you can tell, therefore, if you're in standard simplex or general simplex. And the student said, well, what does that mean? So let me make a video talking about that. So I just made up something out of random, just out of my head. It's very possible that this is not going to work to a nice solution or even maybe a solution at all, but it will still allow us to talk about what we want to talk about. So I just said maximize, where p is equal to x minus y plus 3z, and then we have our subject twos. So that's what ST stands for, subject to. 3x minus 4y plus z is less than or equal to 5, 2x minus y minus z is greater than or equal to 3, and x plus y is greater than or equal to 7. So to set this up, no matter what kind of simplex problem it is, if we're doing it via simplex, we set them all up the same way. We solve, so all our optimization problem, our goal is a positive leading coefficient on p, and we move everything else over to one side so it's all equal to 0. And then introduce slack variables to each of your subject twos. If you do not remember what I'm talking about, you can go back and watch other videos back from the lessons. But the big idea here is note less than or equal to's, greater than or equal to, greater than or equal to. So the slack variable, this one will be a plus. These ones will be a minus. Because if this stuff is greater than or equal to, we need to subtract to make it equal to. And since this first subject to is less than or equal to, we need to add something to it to make it equal to. So I've gone ahead and already set that up in a matrix, just to save a little bit of time. So this is what our matrix would look like. Now, on the midterm, you may remember I gave you a problem similar to this, where I just said, circle the next pivot. I didn't give you the start. I didn't give you the setup. I didn't tell you what you were doing. You didn't know where the problem originally started. I said, here's your matrix. Determine. What are you doing? So how we check to see if it's standard simplex or general simplex is and especially just we learned this in general, is what your first step you do is you say, okay, any column that has more than one value in it, think of those as equal to 0. So x is equal to 0, y is equal to 0, z is going to be equal to 0. So now what we're left with is q is equal to 5, r is equal to -3, and t is equal to -7. And if you really wanted to, you could come down and check. Whoops, excuse me. Yeah, my finger caught the Windows button. And then let's see. And then if you really want to, you could do p is equal to 0, but that doesn't matter. We don't really have to worry about it. So the idea here is saying, okay, we know we are in a general simplex problem because one of these values here has a negative value. The r has a negative value and the t has a negative value. So I need to star the r and star the t. And it doesn't matter if it's the first step or the 17th step of the 17th pivot of a matrix. If you have a negative answer, you're starring rows, you're doing general simplex. So I hope that answers your question of how do you tell if you're in general simplex? Well, it's just by how we read our answers. How you read off your values. What you're going to do is just say, is it a positive or a negative number? If they're all positives, standard simplex. If even one of them comes up as a negative, general simplex. Okay, hope that helps.